All right, so what we have today is refurbishing this concrete uh, cutting saw that was in a flood, and it looks a little beat up. And we had this probably for the last 10 years, and it worked great, and then it was in a flood, and then it was kind of forgotten about because we were just subbing concrete cutting out to cutting companies. So I took it out and I am starting to refurbish it. I took all the covers off like that, all the protective covers. The wheel goes here, the big 2-foot diamond wheel. And then the water inlet goes here to keep the dust down. This is the differential transmission, as they call it. That works fine. I tried forward and reverse, so that's in forward, and then you come over here and this transmission nozzle knob right here. Now that's in reverse. So that works great. The blade shaft spins freely, so that works. Now the last thing besides the electrical box on top, which I should take apart and check all the connections, is the 7.5 horsepower motor that I can buy a new one, but I'm going to see if this works. I loosened the adjustment screw and took the 3 belts off that go to the cutting shaft, and it seems like the motor is completely locked. I did rebuild this electric pipe threader for jobs, so that had an electric motor in it that was completely locked. I took it all apart and cleaned everything and put it back together. It was just rusted. The gears were just rusted together, so it wouldn't move. But I cleaned this up and it works great, so that this is hopefully the same problem as the other one. This is the Core-Cut CC 1800. This thing is like, I think I last looked online, it was like $4 grand to buy, depending on where you get it, 3,500. So I definitely want to see if I can get it going and use it, because it'd be a lot better than buying a new one if I had to. That thing is not moving at all. So I think I'm going to have to dive deeper, unfortunately, into the motor. So that really doesn't look too good either. So I'm going to wait to take the wiring apart. I have this box down here apart. It looks just as cruddy as the other one, but a little voice in my head said, see if you can get the motor apart while it's standing on the actual machine. It could be a huge mistake, but we will find out. I was going to give this a spin, but it's only cheap plastic, so doesn't help. There you go. One. I'm going to loosen up the other side. I got to take this pulley off. Okay, so I have to temporarily wire something into this panel. The sub panel is off. I double checked with the welder. You can never be too sure. So I'm going to disconnect this outlet that I use for all my welding stuff. I'm just going to disconnect it from this 50 and then leave it hang and then wire this up. Now this is only a 3-wire because there's no nothing on the machine that needs 120 volt separate. So these are two hots, single phase, 240 volt, and then a ground. All right, nothing blew up, so that's a good sign. I might as well test out our 50-foot cord too we use. Okay, that's snapped in. Okay. Snap this in. All right, this is the truth, the moment of truth. Let's see if I'm lucky. All right, I'm getting nothing. All right, so I have my little tester light here. So let's see where this power is and isn't going. So here's the ground on down here, which is cruddy. And then, so that's the green ground wire right here. It's hard to see on camera, I'm sure. So, ooh. All right, so we have 240 across the board here. So I know I have electric going to this. There's nothing wrong with anything to here. I guess I should check the switches first. So we do have 240 across that. And then the off is obviously off. Even when I hit the switch. I'm going to take all this apart, clean all the connections up, and then I'll try again. All right, so the ground bar is clean. I'm going to turn the electricity back on and see what happens. Hit the on switch. Nothing. I cleaned everything, took it apart, cleaned all the grounds, cleaned all the contacts, cleaned, spit shined it, blah, blah, blah. Now, let's see if it turns on, do a little dance, a little prayer. So those, well, it turned on, yay. But those fuses are getting red hot. And all right, watch these fuse bridge link things. They do get red hot. I wonder why. I think it's pulling too much voltage, and then these are getting red hot and it's tripping off. Oh, what's this? Reset switch? Whatever. I'm gonna call the company tomorrow. I'm gonna start putting all this back together. So I called the manufacturer of this, and he told me to first look at the run capacitor and the starter capacitor, which are under this huge cover that sits like this. And I look underneath, and I started it one more time, and those contacts are still glowing red. So I opened this up, which I should have done from the beginning, and it looks like one of the capacitors has actually blown apart. So I'm just going to get 3 new ones. That's never a good thing. If both of them are broke, I'm not sure if something caused them to break or they are the cause. Okay, so after talking to a couple electric motor repair places, I'm starting to feel like there's a short inside the motor, which is causing an overdraw of electricity through the magnetic starter switch, which was the reason why the coils popped, the capacitors popped. So I'm going to be taking all of it apart and taking it to a repair shop. The guy's going to let me know if it's worth rewinding the motor, if it's fixable, or if I should just buy a new one. All right, wish me luck. All right, so look what I just picked up, a score. I hit a jackpot. Some guy was getting rid of this brand new ball door motor. It's essentially the same exact thing that was on it already, so I got super lucky. It's 7.5 horsepower and 20 amps. Same frame, 213T frame. 3-phase, and it fits that hole. It fits perfectly, so I don't have to do any modification. I'm trying to find a pulley that's identical to the other one, and it's proven difficult. And another thing that's not a big deal is the RPMs are 1770, and the old motor was 3400. So I have to double the size of the pulley on the motor, or half the size of the pulley on the secondary pulley. This pulley is a 2.5, 2 3/4, somewhere around there. So I need to get a pulley double the size. All right, this holds the blade. There's a little notch. So I'm going to get the circumference of that pulley, or the circumference, yes. Okay, so this pulley here, it's hard to tell, but 3.5 inches outside diameter. So let's do some math. All right, so I went on the Diamond Product Core Cut website, and they said that recommended is 2,500 RPMs for the blade. So that's pretty much the small pulley being the motor and the large pulley being the blade at the 3,450 RPM was around 2,400, so that they're essentially where they said. So since I have a new motor at 1770 RPM, and the bottom pulley I'm going to try to keep the same, so I will have to find a 5-inch pulley, and that'll bring me exactly 2,500 RPM. So somewhere around there will be nice. Okay, so I got the new motor for this. Finding this pulley is like impossible. You can't find a 4 pulley, 4 groove, 3/16 plus a type A 1/2 inch pulley to go down, and then the 3/16 from there go down to this pulley that I can't find another one that's the A type, and I found one that I'd have to put 2 together. It ended up being like $400 for this 2 pulleys, and then another like $400 for this pulley, and then I would have to buy the phase 3 box, 3-phase box. So new plan. I bought a new motor, another one. So I bought a single phase box, magnetic starter. And what I did was I mounted it to the backing plate of this waterproof box. And so I'm going to slip that in there. I took it out of this box. And I have this on-off switch. I bought 2 momentary switches, so you just push it and it stays on. This one has a lock on the on button and stays on. So if it were to trip and then the power would reset some magical way, the machine would start up again and it'll be like a safety hazard. So that's why the momentary switch is good, because when you have a momentary switch and you hit the on button, it springs back until this either shut the momentary off button off, or this trips and it has no more power, so there's the saw can't start to run again if the breaker resets. So I have to wait for the new motor to come in, but I'm gonna wire this in the meantime. Here's a little demonstration. I have a breaker temporarily wired to a 10 gauge 3-wire, 2 hots in the ground, no neutral to this. It comes up to those 2 points there, these 2 contacts, and then there is a the overloads are here in case your motor is drawing too much power. That will trip a little breaker right there, and then the red is the reset button. So pretty much there's a coil, the 2 prongs, the 2 screws behind there, they go to this normally closed switch, and then it runs back to the coil on the other side. So you run 240 volt to the coil, and the when you turn the power on, and I jump the coil with this off-on switch. So to activate the coil, you turn it on, and it sucks in the magnetic starter. So now I have power to the 2 contacts right there. That'll go to your motor, and then the off switch to break the flow of electricity to the other side of the coil off. So it's super simple. If you want just a regular on-off switch. Okay, so I wired the momentary switches for safety purposes, so that if the breaker trips and you have a momentary switch that's spring-loaded, it won't turn the machine back on when the breaker resets. So another way to wire it is you have power coming into L2 here, 1 hot, 1 leg of hot, 120 volt. Red wire, follow that lug down to the overload here, and this is closed, so this is always on until the breaker reset, until the overload trips. So then you come back here, follow that other red wire, and this goes to one side of the coil. The magnetic coil is what completes these contacts inside this to run power down to your lugs going out to your motor. So you have this side of the coil energized. This is the coil underneath here. You have this side energized. Now you need to get to this side of the coil energized. How do you do that? So you run so you take this hot, so this is going to be the other leg. Doesn't matter which one, L1, L2, they're both hot. You grab this wire off the hot, you come down and you go to your normally closed switch. So this switch can be wired normally closed. So see, when I hit the button, it breaks it, which is labeled red nicely for this switch. And then the other side is green, which is normally open. See how there's no contact there. And then when I hit it makes contact. So you wire it through either side of the stop switch, and then you wire the power. The power goes through the stop switch and either goes to your start switch and to one side of, I had to buy a separate normally open auxiliary contact. There's the part number, 9999D10 for this old square D style. And there's that part number. And that's a 7.5 horsepower. So, single phase. So, you have this side. So when this magnetic starter closes, it pushes that as well. So that's connected. And that completes that circuit. So to get power to the other side of this normally open, now we have power to this green normally open start switch. So we have power to this side of the switch. Well, how do we get power to the coil? When you hit this green button, boom, it touches. Now we have power running through the other side of this switch up to the other side of the coil. So now you have electricity running through everything. Everything's good. Well, when you hit this and let go, that breaks contact. But this normally open switch will keep power since you jumped the coil to this normally open. Now this is closed, this switch, and the magnetic starter is closed. So it's sending power through and everything's good until you break that flow of electricity to these two switches here. And you hit the stop button. Because it's normally closed, this side is normally closed, there's electricity running through it. Then you hit the stop button. No more electricity running through, everything stops. The magnetic coil starter opens up, becomes an open switch, and the machine is ready for you to complete the electricity flow again. You hit the start button and it starts flowing all over. So that's another way to wire this. And then I'm going to drill my holes in the cover and I'm going to make this look pretty. Temporary power. So we have, right now there's these two wires here plus the ground to the box. So we got power to these two lugs. So now we have power to that side of the coil, like I was explaining, and then from this side of the coil, we need to power up to send electricity through to our motor. So we have power from that lug around to this stop, through the stop because it's closed. That means the contacts are touching. Power to this side of the open contact here, auxiliary contact. And we have power to one side of this start switch because it's open, they're not touching. So we have to hit that start switch and the power runs through that wire to the coil, closing the coil until we break the power with the stop button. So as you can tell, the coil is open right now until we hit the green start button, and then it shuts. Now that sprung back, but the coil held because it's getting 240 volts to keep electricity flowing through. Now we have electricity to both our lugs, to the motor spinning, destruction happening, madness, until we shut it off with this red button to break the electricity flow, and we're off and everyone is safe. All right, so let's hook it up for real, for real. Before I put everything back together, it's decently nice out. I can finally give it the hose, rinse it off. I have everything wired up. The motor came in. I got a WEG from the people saying it's they're pretty good now. They used to be complete crap, but people had good luck with them. WEG 7.5 horsepower, single phase. I drilled 2 new holes in the box for the start and stop. I have the box wired up like you saw before. This is first test run. Then I'm going to put all the bolts and widgets back in. Put your glasses on because you never know what's going to happen. Hit the green button. And it runs. That is fantastic. It's very quiet too. Okay, and it's going the correct direction, which is also good. Okay, let's put everything together. All right, this is the first pulley is for the transmission. So get that kind of in line with there. Keep going. Okay, that looks pretty good. All right, that one of these pulleys, I'm only using 3. So there's a 1, 2, 3 on the outer edge, and that'll connect to 1, 2, 3 here. So for the transmission, that wheel there connected to the transmission connects to the wheel hitting the floor. So when you lock the transmission, when you push down the lever, it pushes against the wheel and then locks into place there. This is the forward and reverse. Super simple. So I'm going to turn it on and you can watch the gear right there spinning back and forth. Forward, backward. So there's forward, backward. Beautiful. Last but not least, to control the blade, put the 20-inch or 14-inch blade on there. You got this, the last 3 belts, and there's a lot of slack in that. So to tighten that, you tighten that nut. All right, belts are pretty tight. I'm on my old line. Just need to tighten that and that up to lock it in. And I think there's 2 more back there somewhere. I'm gonna have to go over every bolt because I kind of forget what I loosened and whatnot. last but not least, I put all the safety panels on. There's one on that side, two on this side. Pretty obvious my miscalculation. There's the shaft of the motor right there. So I guess this shaft is longer than the one that it came with. I was thinking about cutting it. Maybe I'll cut it later, but I'm just gonna put a little safety cap or whatever you want to call it on that. But luckily that clears, barely. So I put the blade guard on. I found a nice, almost new looking blade, so pretty happy about that. And last but not least is get your pointer and align it with your blade to show you where you're going. And that is it for this video. I can't seem to find the things to hold that box down, but luckily it's only 11 at night and I have a job tomorrow at 6 using it. So this might have cut it a little close, but we made it. So I am ready. Hook up my water here, spray it down the thing, and you're cutting. So see you on the job.